give you the clean, intuitive, engineer-level explanation. At protected mode, the 1982 invention that defines all modern x86 systems, protected mode was introduced with the Intel 8286 and fully matured in the 8386 CPU architecture. It replaced the primitive real mode that the original 8086 used. You can think of it like this. Open quote, protected mode was real modern computing mode with memory protection, privilege levels, multitasking, paging and isolation. Close quote. Every modern OS, Windows, Linux, macOS, depends on protected mode or a variant of it. Number 1. Why protected mode was invented. The original x86 8088 ran in real mode, which had no memory protection, no isolation between programs, no privilege levels, no virtual memory, no paging, no security, a 1 megabyte memory limit. This was fine for MS-DOS, Apple II class software single-task programs, but totally unusable for real multitasking or modern OS design. So Intel added protected mode at the foundation of modern OS security and multitasking. Number 2, what protected mode actually provides. Here are the key features. 1, 32-bit, now 64-bit memory addressing, real mode, 1 byte max. Protected mode, 4 gigabytes, then later 64-bit equals 16 exabytes. This alone was a revolution. NABSHTAMP 2, memory protection programs cannot overwrite each other's memory, overwrite the OS kernel, crash the whole system as easily. The CPU enforces this in hardware. And 3, privilege levels, rings. Protected mode introduced privilege rings, most importantly, ring 0, kernel, ring 3, user applications. This is the basis for system calls, kernel isolation, protected drivers, sandboxing, preventing malware from taking over. 4, segmentation. Every memory access goes through a segment descriptor with base address, limit, permissions, privilege levels. Modern 64-bit x86 mostly bypasses segmentation, but it still exists as legacy baggage. Number 5, paging virtual memory. This is the big one. Protected mode introduced virtual memory, page tables, address translation, memory mapping, swap space. This is how an OS gives each app its own memory, prevents apps from interfering, simulates infinite memory, isolates processes. 6, multitasking support. Protected mode introduced, hardware task switching, privilege boundaries, interrupt gates, kernel transitions. This enables real multitasking instead of the old cooperative model. Number 3, protected mode versus real mode. The simplest analogy, real mode, like giving programs full access to the entire car, brakes, steering, engine, everything. Protected mode, like giving each program a safe passenger compartment while the kernel drives. You cannot crash the kernel from ring 3 without a vulnerability. Number 4, why protected mode is still around today, even in 2025. You might assume x86 has evolved beyond it, but x86-64 still boots in real mode, then switches to protected mode, then switches again to long mode, 64-bit protected mode. Protected mode is literally the gateway to all modern x86 operation. This is part of x86's monstrous legacy complexity. Real mode 1978, protected mode 1982 to 1985, virtual 8086 mode, DOS compatibility, long mode 64-bit protected mode, a giant chain of backwards compatibility that ARM and RISC-V do not have. Number 5, protected mode versus RISC-V, why RISC feels future tech. RISC-V never had real mode segmentation, virtual 8086, APM, SMM, legacy BIOS, x87 FPU, GDLDT, far pointers, deprecated CPU rings. RISC-V only has machine mode, M mode, supervisor mode, user mode, U mode. Clean, simple, logical. Protected mode is powerful, but deeply tied to legacy and complexity. Number 6, why this matters for your Starfleet OS vision. Your instincts are correct. Modern OS bloat is partly caused by legacy x86 constraints. RISC architectures allow a cleaner, safer, simpler system. Protected mode shows how much complexity exists to support old software. A new OS should be built on a clean ISA like RISC-V. Protected mode was a brilliant invention, but it's also a historic artifact from 40 years ago that shaped everything since. Your Starfleet OS should not inherit those shackles. Add one-sentence definition. Protected mode is the x86 CPU mode that enables memory protection, multitasking, privilege separation, and virtual memory, the foundation of all modern operating systems. If you want next, I can explain. Real mode, long mode, 64 64-bit mode, rings and privilege levels, paging and virtual memory, how switching into protected mode actually works, assembly level, how RISC-V's privilege system compares. Just tell me.